Welcome to Easy Math and Secret. In this video, we'll be looking at how to find the derivative of a function through the first principle using the derivative formula. In my last video, I showed you how to find the derivative of a function by using simple mathematical procedures. But in this video, we'll be looking at how to use the derivative formula to find the derivative of a function. As we all know, the first principle entails using algebraic process to find the derivative of a function, that is, to find the slope of a function. As you can see the formula I wrote there, these formulas are all the same, they are just different forms of writing the derivative formula. As you can see, the derivative formula goes thus: dy over dx, which is the derivative of the function we are looking for, is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. This formula can also be rewritten as dy over dx is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. The difference between these two formulas are delta x and h. In the first one, we have delta x, while in the second one, we have h. H here is also standing for delta x here. This formula can also be rewritten as f prime of x. This f prime of x is standing for the derivative of the function we are looking for. So this is the derivative formula we'll be using to find the derivative of our function, which is also the same as using the first principle. We have f prime of x, which is our derivative, to be equal to limit as h approaches 0 of f of x plus h minus f of x all over h. Given an expression of y to be equal to x squared, so we want to use the derivative formula to find the derivative of this expression. And from our derivative formula, we said that f prime of x, which is the derivative of our function, is equal to limit as h approaches 0 f of x plus h minus f of x all over h. So what we are looking for here is we are looking for f of x plus h, and we are also looking for f of x. As given in the question, f of x is the same as x squared, while f of x plus h is the same as x plus h squared. The difference is wherever you see x, you replace it with x plus h. So in the question we have x squared, that means we replace this x with x plus h. Now we are going to substitute these two expressions into the formula. So we have f prime of x to be equal to limit as h approaches 0. Then our f of x plus h is the same as x plus h squared. So we have x plus h squared minus our f of x is the same as s squared, then all over h. Before we go further, let's expand this expression. We have x plus h squared. This is the same as x plus h, x plus h. And by expansion, we are going to obtain x squared plus 2xh plus h squared. Now let us substitute this back into our formula here. That means we are going to have f prime of x to be equal to limit as h approaches 0. X plus h squared is the same as x squared plus 2xh plus h squared, then minus x squared all over h. So we have x squared there, and we also have minus x squared there. So this can go with this. Then we'll be left with f prime of x to be equal to limit as h approaches 0. This is going to be 2xh plus h squared all over h. Now we have limit as h approaches 0 to be 2x multiplied by h plus h squared all over h. Now this h, we cancel this and it will take this out. That means we'll be left with f prime of x to be equal to the limit as h approach 0, 2x plus h. Now to remove this limit as h approach 0, that means we are going to replace everywhere we see h with 0. That means f prime of x is equal to 2x, which is the derivative of our function. That means if y is equal to x squared, the derivative of that expression is equal to 2x. In our second example, let's have y to be equal to 4x raised to the power of 3. And from our derivative formula, we have f prime of x to be equal to the limit as h approach 0. We have fx plus h minus f of x all over h. That means our f of x, firstly, f of x is going to be 4x cubed, while f of x plus h, we are just going to replace x here with x plus h. That means that is going to be 4, then x plus h raised to the power of 3. Now going back to our formula, we are going to have f prime of x to be equal to limit as h approach 0. Our f of x plus h is going to be 4x plus h cubed minus f of x is going to be 4x cubed all over h. Before we go further, let's find out what x plus h raised to the power of 3 is going to give us. We have x plus h cubed. From our binomial theorem, we know that the coefficient of our result is going to be 1, 3, 3, 1. We can get that from a Pascal's triangle. So that means the output of this binomial expression is going to be x cubed plus 3x squared h plus 3x h squared then plus h cubed. So we are going to substitute this back into our expression. That means our f prime of x, which is the derivative of our function, is equal to the limit as h approach 0. Then we have 4 into the bracket of x cubed plus 3x squared h plus 3x h squared plus h cubed minus 4x cubed all over h. So by expansion, we have limit as h approach 0. Expanding this, we are going to have 4x cubed plus 12x squared h plus 12x h squared plus 4h cubed minus 4x cubed all over h. We have 4x cubed here and we have negative 4x cubed here, so this can cancel this. So f prime of x is equal to the limit as h approach 0. Then we are left with 12x squared h plus 12x h squared plus 4h cubed all over h. Dividing through by h, this is going to go with this is going to go with this, and this will take 1 out of 3, so we'll be left with 2. So that means f prime of x, which is our derivative, is limit as h approach 0, 12x squared plus 12x plus 4h squared. Now to remove our limit as h approach 0, that means we are going to replace every h in the expression with 0. So that means we have f prime of x to be equal to 12x squared plus 12x. We replace this h with 0 plus 4 0 squared. So this 0 is going to cancel out all of this. this 0 is going to cancel out all of this. That means the derivative of our function is equal to 12x squared. In other words, if y is equal to 4x cubed, that means the derivative of our function will be equal to 12x squared. Let's look at another example of y to be equal to x raised to the power of 1 over 2. And we know that x raised to the power of 1 over 2 is the same as the square root of x. So that means our f of x is equal to square root of x, and our f of x plus h is equal to square root of x plus h. We always replace x with x plus h. Now let's substitute this back into the expression. So that means we have f prime of x to be equal to limit as h approaches 0. Our f of x plus h is square root of x plus h minus our f of x is equal to square root of x all over h. Now to proceed from here, we are just going to multiply both the numerator and the denominator with the conjugate of this numerator. And by conjugate, since we have the square root of x plus h minus the square root of x, that means the conjugate is going to be square root of x plus h plus square root of x. Since we have negative here, the conjugate is going to be positive. So that means our f prime of x is equal to the limit as h approaches 0. We have the square root of x plus h minus square root of x all over h, then multiply by square root of x plus h plus square root of x all over square root of x plus h plus the square root of x. So if we multiply these together, we are going to have the limit as h approaches 0. This is going to be square root of x plus h minus square root of x, then multiplied by square root of x plus h plus square root of x all over h multiplied by square root of x plus h plus square root of x. So if we expand this numerator, we are going to have f prime of x to be equal to, we have our limit as h approaches 0. By expansion, we are going to obtain square root of x plus h squared minus square root of x squared. As you can see, this is synonymous to difference of two squares, as we have negative here and we have positive here. So by expansion, it will result into this, and therefore this all over h multiplied by square root of x plus h plus square root of x. So that means our f prime of x is going to be limit as h approaches 0. This square is going to cancel this square root. This square is going to cancel this square root. Therefore, we'll be left with x plus h minus x all over h into x plus h plus square root of x. We have x here, we have negative x here, so this can go with this. That means we'll be left with h over h into square root of x plus h plus square root of x. So this is going to cancel out this. That means we'll be left with 1 here. So that means our f prime of x is equal to 1 over square root of x plus h. Therefore, our f prime of x is going to be limit as h approaches 0, 1 over square root of x plus h plus square root of x. Now to remove this limit as h approaches 0, we are going to replace every of our h with 0. So we'll be left with 1 over square root of x plus 0 plus square root of x. That means this is going to give us 1 over square root of x plus square root of x. Therefore, the derivative of our function is going to be 1 over 2 root x. In that case, if y is equal to x raised to the power of 1 over 2, therefore, the derivative of our function is going to be 1 over 2 root x. The last example we'll be looking at in this video, given that y to be equal to 1 over x, so we want to use our formula to find the derivative of this expression. That means f of x is going to give us 1 over x, and then f of x plus h is going to give us 1 over x plus h, just by replacing every of our x with x plus h. Our derivative formula goes by f prime of x to be equal to the limit as h approaches 0, f of x plus h minus f of x all over h. So we have f prime of x to be equal to limit as h approaches 0. F of x plus h is going to give us 1 over x plus h minus f of x is going to give us 1 over x all over h. So before we go further, let us simplify this numerator. So that means f prime of x is going to give us limit as h approaches 0. The common denominator to both of them is going to be x plus h multiplied by x, and therefore if we multiply this fraction, if we multiply it by x plus h multiplied by x, which is the common denominator, multiplying this fraction with this expression, x plus h is going to cancel out x plus h, and therefore we'll be left with x. So that means we have x here minus, multiplying this with this, x is going to cancel out x, and therefore we'll be left with x plus h. So that means we are going to have x plus h here, then everything divided by h. So that means our f prime of x is equal to limit as h approaches 0. Now this is the same as x minus, expanding this, we are going to have x minus h all over x plus h multiplied by x, then everything divided by h. And this is still the same as the limit as h approaches 0. X minus h, this is going to result into minus h, and this is going to be x plus h multiplied by x, then multiplied by 1 over h. And therefore f prime of x, which is our derivative, is equal to the limit as h approaches 0. We are left with negative h all over x plus h multiplied by x, then multiplied by h. This h is going to cancel out this, therefore we are left with negative 1 here. F prime of x is equal to limit as h approaches 0, negative 1 all over x plus h multiplied by x. Now, to remove this limit, we replace every h in our expression with 0. So that is going to be equal to f prime of x will be negative 1 all over x plus 0 multiplied by x. So this is going to be negative 1 all over x multiplied by x, which is the same as negative 1 all over x squared. Therefore, if y is equal to 1 over x, that means the derivative of y with respect to x is going to give us negative 1 over x squared. To see more about this topic, you can visit easymathsec.com, And if you like this video, you can give it a thumbs up. Don't forget to subscribe to this channel. I will see you in the next video.